Okay, let's start by creating a new app from a template in Qt Creator. For that, we first have to start Qt Creator, which obviously depends on your operating system on how to start it. Okay, so no matter which operating system you use, Qt Creator should more or less always look somehow like that. You get this nice starting page with previous projects you worked on. You have here this sidebar, we come to this later, and probably most important because a lot of the actions are hidden there, the menu bar. Okay, first of all, let's create a new project. So for that we select File, New File or Project, or we can just use the shortcut Ctrl+N. Okay, which should bring up this dialog here. In this case, we have in the left column two sections. One's for files and classes. We can ignore this for now. And the second one is a section showing the available projects. So here we have applications, library, other projects, and so on and so on. And here basically we want to select Qt widget application. By the way, if this entry is not showing up for you, watch out that here in this kind of filter you have either desktop templates selected or all templates. For example, if you have only Android templates activated, then this entry might go away. So you see some entries get filtered out. So if you don't see something you would expect there, ensure that here no filter is set. Okay, for now, let's select this entry, click on Choose. Good. Next, we have to give our project a name. So in our case, of course, something like AddressBook. And we have to select a place where to store it. Okay, let's create a new directory first. Okay, so if you want, you can also check this option so that this directory, in this case Qt Training, would be the default location for following projects. I don't want to, so just continue. Okay, in this dialog you get the available, let's say, target architectures for which you can, or for which your Qt Creator can create executables for. So in my case, as I have both desktop Qt versions installed as well as Android ones, I get a lot of options here. However, for me, all I want to do is basically this one here, desktop Qt 5.5. That's enough. So I deselect all the other ones, and we could also, by clicking on details, configure some of the, or in this case you can configure the locations where the build files will be put. So Qt Creator by default uses shadow building. That means if we check the path here, that's the path that I selected for the project to be stored in, and basically our project will be stored in a subdirectory called AddressBook below the directory Qt Training, and next to it we get this build minus AddressBook minus and then the target name directory where all the build files land up. Okay, let's collapse this and just select next. Okay, in this page we can give names to, well, first of all, the main window class that will be created. So this is a class which represents our, or the main window of the application that is going to be created, and we can select the base class for it. So I think the defaults are quite fine, so let's keep this at main window. Here you have some other possible values, QWidget, QDialog, but again QMain window is just fine for us right now. We could also, if we want, change the file names. So usually they are derived from the class name. So if I change this here, main window test, then you see the file names get updated correctly. Okay. What you could do also is here change the file name extensions. For example, if you prefer HPP, you could just append this. For us, as this is following Qt's file naming guide, we just use .h. Okay. This part at the very bottom here, that's about the UI of our project. So this file main window UI will contain the UI definitions. We can also omit generation of this file by removing this box, but for us it doesn't make sense, so just keep this ticked and also keep this entry as it is. Then click next. And here in this last page we can also select a version control system. So Qt Creator detected that I have Git available, so I could select this. So this would cause Qt Creator to automatically create a Git repository out of the newly project directory that is getting created. So if you like, you can use this option to have your version immediately versioned, or your project immediately versioned. Sorry. However, for us, we don't really require this, so we keep this at none for now. Okay, then we just click finish, and now Qt Creator is doing some work in the background, and now it already finished. Good, so you see here in the left sidebar we switched to the edit area. So to go back, we could click on welcome. Okay, and this the main area of the window is filled out by the source editor. So you see we already have the main window.cpp file open, and on the left side here we have the projects pane. So here we have all the open projects, currently only the AddressBook applications that we created, and below the list of open documents. Okay. If we look at this, or at the created structure of our project, it's really pretty small, only consists of very few files. So let's quickly get through the list. So let's start at the very top, at the addressbook.pro file. So these are kind of the project files. They're used by Qt Creator, or better QMake, the build system, the build utility that comes with Qt, to configure your project, to list all the source files, the header files, and so on, which is then used to generate make files from, at least in most of the cases, which are then used to build the final application. So as I said, these files are used to list the source, or basically all the input files. So we have these sections here, sources plus equals to, and then we list the source files that our application consists of. So in this case, our main window.cpp class or file, and the main CPP file, this one here. Same for the headers. Here we only have the main window.h header file, that one, and forms main window.ui. This is this file here. Okay. This file does not only list input files to our project, but also is used to, let's say, configure our project. So, for example, by setting the Qt variable, we can add or remove modules of Qt that we are relying on. So in this case, our application requires the core and GUI module of Qt, and in case of Qt 5, also the widgets module. This is because GUI and widgets parts have been split up when transitioning from Qt 4 to Qt 5. Okay. If you don't care about backwards compatibility to Qt 4, and in our case we don't, what we can do is basically just remove this test here, add the module to this line, and shrink this file a little bit. Okay. Next. Next we have this target and template variables here. So let's start with template. Template basically tells QMake or Qt Creator which kind of object we want to create. In this case, we set it to apps. That means Qt Creator will create an application for us. So on Windows, .exe file on macOS, an app bundle on Linux, and executable. Okay, there are also other templates available, for example, for libraries, for subdirectories project. We come to this in a later session. However, for now, that's enough. And target is here basically the name of the objects that we want to create. So in this case, it's set to AddressBook. That means the output executable file also will be called AddressBook, as we'll see later. Okay. These are only very few available variables. There are a lot more. So if you want to learn more, I would recommend you go to the built-in help. Here select index and search for QMake. And here you find this page, QMake variable reference. Okay. So you see here's a huge list of available variables which you can use to fine-tune the build. So that gives you already a lot of freedom. So that lets you, for example, add special compile flags, linker flags, and so on and so on. You can also add custom targets to your make files. You can invoke custom compilers, and so on and so on. Good. Back to the editor. One variable is not used here, but that I want to definitely mention, as you'll see it quite often, is the config variable. So this variable is often used to pass in flags to QMake to configure how your project is built. So you could use it, for example, to filter on whether to include certain files or not. So you could add or via compile switch deactivate certain features of your application or libraries, or activate a special workaround for certain target platforms or a certain target audience, and a lot more. However, it's also used to control some more basic functionality and behavior. For example, we can use it to enable C++11 support. So let's do this. So usually you should use config plus equals, because that will append something to config. As in most of the cases, this variable already contains some values. As I mentioned, it's in most of the cases initialized from the outside. And then we just pass, in this case, C++11 as an option. So this will cause QMake to generate make files which contain compile switch to the C++ compiler, which in turn enables the newer C++11 language features. If you omit this option, the current behavior is still to deactivate this option or this features, which will cause us to not be able to use some of the more interesting features of Qt that are new in Qt 5. As we don't want this, turn this C++11 mode on. And now let's continue. And of course, save before. Good. The next file we want to look at is the main window.h file. So pretty standard. So here we have the definition of our main window class. So you see, as we've said in the creation wizard, the class derives from QMainWindow. It has a constructor, destructor. It has this private member variable UI, and here's a forward declaration. Why is that? That's to encapsulate the actual UI. So QMainWindow, let's check this in the help, is basically encapsulating or representing a single window on the screen. However, by default, it's of course empty, so in a schematic drawing, it would somehow look like this. You have a window, then usually a menu bar, a status bar, then you have toolbars that you can position all around. You have dock widgets, and then there's a central widget. However, all of these areas are by default empty. So if we start the application, which we could do right now by or pressing Control and R for run, or using build and run. Here we have it. Okay, takes a moment, and here we go. And you see, as promised, it's pretty empty. Well, this will change. So as I said, the actual UI is a little bit hidden. That's done via this forward declaration. So this UI namespace and inside second class main window, which is of course a different one than this one. And this hidden class is kind of a builder that creates the UI for our class, which in turn is defined in the main window.ui file. Let's open this one, and this brings us into the design panel. Okay, and here we basically could create the user interface for our application. So we can start by maybe increasing the window size a little bit, and then here on the left side you have a lot of predefined components available. So there are, for example, push buttons. There are, what else do we have? CD number panels, we have progress bars, there are even calendar widgets. Definitely a lot to play with. Now if we save this file, Ctrl S, and again running our application, magically all of the components are here. Great, so it works. And how does it work? For that, let's switch to main window CPP, which contains the implementation of the constructor and destructor. And in the constructor we see we first of all call the base classes constructor QMain window with the parent which we pass through. So we come to this later. And then we create a new UI main window, assign it to the member variable UI, and then call its setup UI method with the this pointer. And what will this do? Well, basically in this file we also include this other header here, UI underscore main window.h, and well, wait, where does it come from? So it's definitely not listed here. And the answer is quite simple. So this file UI underscore main window is generated from our UI file. So during the build, from this form that we visually designed, a pair of, which is basically an XML file, a pair of header and source files will be derived, which is then included in our main window definition and used to set up the interface for us. So if we would look into this, it looks pretty crowded, so that's definitely nothing that you want to write manually, and it's getting more complicated the more components you add, of course. So basically this generated class holds all of the components that we placed in our form in the visual editor, and then when we're calling setup UI, these widgets get added to the main window in the end. Okay, let's close this for now. And to finish, here in the destructor we of course get rid of the UI again, as we have created it on the HAB. And that's it for now. Good. Then the last file that Qt Creator created for us is the main.cpp file, and that one also looks pretty standard, pretty boring. So we include our main window header file, we also include the Q application header file. So Q application is a class representing an application with its main event loop for widget applications. And in the main function, what we do is first we create an instance of this Q application, passing through the arguments that the application received on startup. Then we create a new main window instance. We're calling its show method, so this will cause the window to be shown. And otherwise, even if we're calling this a.execute function, which starts the actual application or the application's event loop, the window would be hidden. So by calling w.show just before, we ensure that our window really is shown when our application runs. And this a.exec basically starts internally an endless loop, which waits for user input and dispatches events, for example, also to our main window. And it will never return unless the user terminates the application. In this case, it has an exit code which is compatible with our main function, so we can just return it here. Okay. So next, let us add the most basic class that we require in this application, which would be the class for the entries in our address book. For this, we either can use file and new file or project, or right click on our project and select add new. And here you see the projects selection is gone. We only have files and classes left. We want to click on C++ and here select C++ class. Then we click on choose. And in the following dialog, we can first of all give our class a name. So in our case, as it's the entry class for the address book, let's just call it AddressBookEntry. Then we have to select a base class. So either we can let this as add custom and then just leave this blank to create a new plain class from nothing. However, I would recommend you use QObject in this case, because it brings quite some benefits for us. So you'll see this in a moment. For these options, you can keep the include QObject box selected, the others unselected, that's just fine. And as with the initial project setup, here you also can select the file names. So again, if you want to use a different file name extensions, you can do this. You can also change the location where the files are generally stored and so on. However, the defaults are quite fine for us, so we just continue. And here again we could decide on whether or not to add the newly generated files to Git or not, or any other version control system. And also important in bigger projects, to which of the sub projects to add to. So in our case, we only have our AddressBook.pro, which is our main project and the only node in this project setup right now. So there's only this option. Okay, then let's click finish, and this should create a new file or two new files. We have once here this AddressBookEntry.h header file, which looks like this, and we have the corresponding AddressBookEntry CPP file. By the way, in the standard settings of Qt Creator, you can use the F4 key on your keyboard to jump between the two files, so you don't all the time have to go through the Project Explorer here. Okay, then let's start by having a look at the generated header file. So, of course, because we selected it, it includes the QObject header file, and then it adds or it defines our AddressBookEntry class, which publicly derives from QObject. So what is this? So QObject is a very important part of Qt. It's providing some of the basic and also most interesting functionalities of Qt, like signal slots, like properties, generally introspection, and so on. So if you want to make use of these features in your own class, you have to derive from QObject, and you also have to add this QObject macro in the private section of your class. Why is that? Qt, or better QMake, when generating the make files, will scan files for classes which first of all derive from QObject and have this macro, and in this case invoke a dedicated tool, the so-called meter object compiler, on your header file to generate additional source files. These source files provide the basics or the framework for implementing the Qt specific features on top of the normal C++ language. So again, if you want to use these features, you have to derive from QObject, and you also have to provide this macro here. Okay, and the rest of the file is pretty standard, at least regarding the methods. So we have constructor here and destructor, and what's new is these two sections here. So you should be familiar with public, protected, private. So that's pretty standard C++. However, signals and public slots are not. So these are basically two of the Qt features that are available if you derive from QObject. Okay. Now let's start by enhancing this class a little bit. So as it's an entry in an address book, we need some stuff. So for example, we want to provide names. So for names, we could either use, for example, the string class in the STL, or alternatively, we also could include QString, which provides a string implementation for Qt, and then let add a new private section here and add a new property QString mname, which will be the name of our contact in an address book. So for the sake of simplicity, we will use just one variable to represent the full name, so surname and name, so we don't split this up into variables field. Good. What else do we require? Well, for example, an address. So here we also just use a QString, again for the sake of simplicity. And yeah, what else could we require? Well, for example, a birth date. So for this, again, Qt has something for you, so you can just use or include the QDate header file, which makes the QDate data type available, which, as the name might suggest, represents a date. Okay, good. Then also quite important for an address book are phone or headset numbers. So for this, we could either try to model a certain or an own structure to represent these numbers, or we could just represent them again as a list of strings. And here as well, there is something. So we could include QStringList, which is a linked list of strings. And just use this to represent a list of phone numbers associated with a certain contact. Okay, so as all of these member variables are private, we have to provide getters and setters to retrieve and set them in an instance of an AddressBookEntry class. So we could start now by writing these getters and setters manually. Possible, but Qt Creator provides some tools for you to do this much faster. So for this, let's right-click on one of the members, in this case the name member, and in the context menu you should find this point refactor, and here you should find create getter and setter member functions. Clicking this should result in these two methods to be added to our class. So we have one method which is also called name and which returns a string and is const, so that's the getter, and just below it void setName method which takes again a QString which will override the name. Okay, let's switch to the implementation. So for this you can right click and follow symbol under cursor or use the shortcut F2. So here's the implementation that has been created. So pretty simple. So in the getter we just return the member variable. In the setter we override it. Quite easy. Good. Let's switch back to the header and add the getters and setters for the remaining variables as well. So we could go for each of them and use right click refactor. That's possible. You can also use Alt and return on your keyboard while the text cursor is over the member, and then you'll get this refactoring suggestions in a pop-up menu presented. Then you just have to click enter in this case, and that's it. Okay. Basically, we're kind of done, so the class would be ready to be used. However, we can, let's say, cutify it a little bit more. So I already mentioned these signals. So signals are kinds of notifications that a class can send, so other classes can listen to these notifications and react accordingly when something happens. So this is enabling event-based programming. So you have one class which provides information, which emits information as soon as something happens, for example when the name of the object changed, and other classes can connect to this class. They can listen for this particular event to happen, and only if this happens they really do some work. Okay, so how to do this? First of all, or what can we do? So as I mentioned, we could let our clients know when, for example, the name has changed, the address has changed, the birthday has changed, or the phone numbers have changed. So we would need to add 4 signals for each of these events. So let's go to the signals section. And events are basically just normal methods, or they seem to be like normal methods that are declared here in this section. So let's do so, void. And for the naming, I would recommend you use the name of the property. So for the name property, that would just be name, and then append changed. Okay, that's it. So one thing is, don't try to add an implementation to these methods. The reason is I already mentioned this meter object compiler, which generates code from this header file. This will pick up the signal definitions here and generate some code for you. So if you would provide your own implementation of the method, there would be some conflicts, so the compilation later on would fail. So just don't try it. Instead, let's add signals for the other properties as well. Okay. And now how can we use them? So of course Qt does not know how to make up the connection between our name property and the name changed signal on its own. Instead, we have to modify the setter members or the setter methods. So let's go to the implementation, and here let's do some modification. So in the default implementation, we just override the variable each time. So right now it would be okay to do it like that and just add the event notification. However, it's better to first check if the property really changes. So let's check whether the current value of our variable is unequal to the new value, and only if this is the case, we override our member variable mName. And in this case, we also can emit our signal. So in this case, or how to do this, we use the keyword emit, which is also a Qt special keyword, and then just mention the name of the signal. In our case, it's name changed. And that's it. So each time we change the name of the name property in one of the AddressBookEntry classes, this name changed event is emitted. So objects that are interested in updates to the name of such a class can react accordingly. Now let's quickly do this also for the other properties. Okay, and done. So our class is now Qtified. That means we have our properties, we can get and set them, and upon changing the properties, we will emit accordingly the defined signals, so interested classes can react on these changes. Now we can do one more thing to make the whole class kind of perfect, and this is adding the properties that we defined to the meter object system, or making them available via the meter object system. So the system is a kind of introspection system which allows us to query and read out values at runtime, which is used, for example, in the visual designer that comes with Qt Creator, which is used to change the properties of widgets, for example. But it can also be very interesting for properties of non-visual objects, because you can in fact read out and override properties of objects without knowing their actual type at runtime. So how to do this? Again, we have to go to the private section at the very beginning of the class, and here we can use the QProperty macro to add a new property to the class. So ideally you use Ctrl spacebar to trigger the auto-completion and start to enter Q_property, which already should give you this completion option here. So press enter, and that should bring you to this mode. So first of all, you have to specify the type for the property. Let's start with the name property, which is of type QString. So let's type this down. Okay. Next, you can use tab to jump to the next field here. This already is at kind of the right value, because our property is also name, so that's just fine. And now we could jump through the rest. However, the remaining fields are the same here. What you see naming conventions are important. So if your property is called name, then the getter method, which is denoted by the read keyword inside the specification here, also must be named the same as the property. Same for write. So that should be called set and then property name with the property or with the first capital or with the first character capitalized. And for the or notify, that is the name of the signal that is emitted when the property changed. So in this case, it's or should be the name of the property and then appended changed. If you decided to use other names for your methods, for example, override name instead of set name for whatever reason, then after you inserted the property definition, you have to manually adjust this. So you can use other names, but in this case, of course, you cannot, or the code completion provided by Qt Creator won't support you so much. So if you want to be super fast at typing, stick with the default naming conventions. And then you just have to type two strings, the type name and the property name, and that's it. Okay, done. So that's basically for this class. There is one last thing that I want to mention. So if you're used to programming with the standard template library of C++, then things like this might be a little bit strange. Or even more, this one here. Why is that? With the containers or also string data types of the STL, you would usually return them, if you have a getter, as a const reference, because that's cheaper, as the STL types really get copied when you write a getter like that. Now, with the Qt data types instead, that's a little bit different. So most of the data types that are provided by Qt are so-called copy on write. That means if you create a copy, for example via or when a copy constructor is used, that's quite cheap copy, as the underlying data is implicitly shared between the two copies later on. Only as soon as you try to modify the copy, a deep copy of the data will occur, at which point in time you have to invest kind of more cycles at runtime. However, otherwise, for our usual getters where we really just request some data and then that's it, it's totally okay to not work with references here. So next, let's create a container class for our address book entries, the address book. So again, for this, right click on our project and select add new. Again, C++, C++ class. Here, give it a name. In this case, address book. And again, as base class, we select QObject. The remaining parts remain as they are, just fine. Here as well. Finish, and we're done. Good. Let's change into the header. And first thing here, let's select a container for our address book entries. So Qt provides several container classes again. For example, vector implementation. You also have QMap, you have QHash, which is a hash map implementation. However, these two are not really fitting for this purpose. What we want instead is probably just a simple QList, which provides a linked list implementation. And of course, we also want to include our AddressBookEntry header. Okay, so we see it here, just fine. So next, let's define an alias type. So if we want to use our list type several times, we don't all the time have to use QList and parameterize it with our AddressBookEntry type. So we use QList. This is a Qt list type, and then we parameterize it with AddressBookEntry, the AddressBookEntry or person type that we defined, and we just name this entries. Okay. So this class as well already has signals and public slots section. Let's add a private one where we're creating our private member variable for the entries that are belonging into the address book. Good. Next, let's create getters and setters. Well, getters and setters, in this case, let's only create a getter which returns the complete list. So you can do this by right-clicking, refactor, and create getter member function. Okay. And why not set entry? Well, basically, or it's a good idea that the address book owns the address book entries. That means if the address book is destroyed, we also want to go all of the address book entries away. For this, we have to somehow ensure that the address book is really the owner, and not two address books share the same list of address book entries. If we would provide a simple setter, people could start doing a lot of crazy things with our APIs, so we just don't do this, but instead let's add two other public member functions which we'll use to modify our address book. So how could they look like? So let's do one like this: AddressBookEntry, create entry. So this is a method that we can use to create new entries in our address book. And the second one could look like this: delete entry, which takes an address book entry and tries to delete it, which should of course succeed if the entry we are trying to delete really belongs to the address book, whose delete entry method we're calling. Good. Next, let's also add again two signals to our class, just for the sake of completeness, so we can let the outside world know that the address book has changed. So something like void entry added, and this time the signal gets an argument alongside, which is the new entry that we're or that just has been added to the address book. And the next one, entry removed, which will be emitted as soon as we are deleting an address book entry. Okay, next let us implement the create entry method. So for this, again, we can use the context menu, refactor, and then add definition in AddressBook.cpp. For inline methods, you could also select outside or inside class implementation, or again, you can use Alt and Enter to also get the same options. Again, I'm selecting a definition in AddressBook.cpp, and here we go. Good. Now, how could an implementation look like? Let's try. Okay, so we are calling new address book entry, and as you might remember, the constructor of address book entry took this mysterious parent parameter, which is any queue object, and as our address book is a queue object, let's pass this pointer. That's already quite good. Why? Well, queue objects build up a parent-child relationship. That means if you specify a parent when you create a queue object, then as soon as the parent is deleted, it also automatically deletes all of its child objects. That's very good, because then we don't have to manually take care of removing these objects manually afterwards. So when using Qt, make use of the parent-child relationship as often as possible, as it helps you to write clean code where you have not so many memory leaks in the end. Good. Now let's continue. Actually, we could just finish by saying return result, which is quite fine. Okay. However, we also added this entries member variable, and we surely also want to add our newly created entry to it. However, of course, the creation of the object might have failed for whatever reason. So we should check. So if result is not a null pointer, then let's add our new entry to the list of entries. So we can use mentries.append, and this will append whatever we specify, in this case the value of the result variable, to the end of the list. Okay, that's point 1. And point 2, in our header file, just to remember, we defined the signal, so we also want to make use of it. So whenever we really add something to the list of entries, we should also emit this signal here. Okay, that's it. Pretty simple. Now the same for the entry or delete entry method. So let's add an implementation, Alt Enter, add definition in AddressBook.cpp. Okay. And how could the implementation here look like? So as I mentioned, we have to make sure that we maintain or we follow the ownership of address book entries. So only if this address book is the owner of the address book entry given, we really want to proceed. So how to do this? We could check if the entry is part of our entries list. Okay, so if it is really contained in the list of our entries, then first of all, let's emit the entries removed signal. Why is that? Connected objects that are listening for the signal then still see the entry in the list if they use the address book's entries method. If we would emit the signal right after, they won't. So it depends a little bit on your choice here and on how you want your API to work. In the end, it's a good idea to put these details in the documentation of your methods. So first of all, let's emit the signal. Entry removed. Okay. Next one, we really have to remove this entry from the list of entries. And here we can use the remove either all or remove one method. So remove one has the advantage because we know each instance of an address book entry is stored at most once in this list. So it doesn't make sense to search the complete list for occurrences, but instead the remove all will search for the first occurrence of the value specified, in this case entry, and remove it and then return, which is potentially faster if the search for entry is at the very beginning of the list. Good. And finally, we should also delete the object, like that. And If we took this branch, we should return true. Okay, because then everything succeeded and the entry really has been disposed. If not, so if the entry does not belong to this address book, we should of course return just false to indicate to the caller that a wrong instance of address book entry has been passed to us. Okay, that's it, pretty much it. So we could test to build this using Ctrl B, save all, okay, and whoops, we have one issue here. Entries does not name a type. This is because Qt Creator did not add the, let's say, namespace in front of the type name. So let's add this manually, AddressBook : entries, and try again. Okay, and the second error somehow looks like a typo in my definition, right? So you see here, of course we want this to be, or the list type to be of pointers of address book entries. Okay, now let's try again. And now it succeeded. Very good. So next we could actually start wiring together our user interface and our backend logic. However, I would only recommend this if you're really sure that your application remains extremely small. As soon as your application took growth on the other side, it's a bad idea to do this right now and, for example, directly adding a member of type AddressBook to our main window. So instead, let's introduce a man in the middle, so a kind of controller class which takes care of the communication between our user interface and the business logic. So again, let's create a new C++ class. Let's call it AddressBookController. And again, it should derive from QObject. Okay. So our controller, to do its work, obviously needs an instance of an address book. So we should include the header file first. And in the private section, give it an according member variable, address book. Okay. And how does the controller get such an address book? So either, or the simplest way would be if it would just allocate a new one as soon as it is created. However, that's a bad idea in terms of testability of your code. Well, why? Because it creates dependencies, it pulls in implicit dependencies, which is a bad idea. Better actually is if you pass in these or objects or services you depend on, for example, in the constructor. So this pattern is called dependency injection, and if you plan to make your code unit testable, it's a good idea to use this pattern as often as possible. So let's add a new argument, address book, to our constructor. And now in the refactoring menu, we should have a new entry available, apply function signature changes. So let's select this one to automatically update the already existing implementation of the constructor in the CPP file. Good. So next, let's store our member variable, or store the address books that we get in our member variable, like this. And okay, depending on how you want your API to function, either you could allow null pointers here as well for the address book, and then add, for example, getters and setters to the interface of the controller. However, in our case, and we just add an assertion. That means it's not allowed to create an address book controller without an address book. So this way we can be sure that our address book member variable will always be initialized whenever we are in one of the other methods of the class, and then we don't have to repeat these checks there. So, but again, it's choice of yours on how you want your API to work in the end. Okay. Now the controller needs basically two functions in order to be usable for the user interface, and these functions are basically the same as also the address book has. So we need one to create new entries and one to get rid of existing ones. So let's do this. We have one which creates new entries, and we have one which disposes an existing entry. Like this. So let's add an implementation here. How could this look like? So first of all, we are calling into the address book that we have to create the entry. Okay. And then we could again immediately return it. However, please remember that our address book entries, as we're creating them right now, are completely empty. That means in the user interface, if we are going to show them there or visualize them there right now, we also will see probably nothing because everything is nulled and set to default values. So what we could do, let's pimp the entries that we created. So if we were successful in creating a new entry, so if it's not a null pointer, then let's set the name to something meaningful, for example. So result.setName, and then here, new entry. So that way we immediately see, okay, that's a new entry which is not yet initialized. Okay, before we continue, that's actually a bad idea. So putting a raw string that is going to be shown to the user of your application directly in the code. What is if you want to provide your application in other languages, for example? So Qt provides mechanisms for translating your user interfaces, but it also provides means to translate strings contained in the sources of your application. So for this, just surround all of your strings that you want to be visible to the user in this tr function. tr is for translate. So it's basically not a function, it's a member method of QObject. So this method is available in all classes that somehow derive from QObject in the end. Okay, so by doing this, we will be able to translate the string later on, and if we are providing our application, for example, in German, then we also can just translate this to the according German translation. The same applies for any other language as well. Okay, so now we're basically done already with the creation. We also have to, of course, implement deletion, which is in this case a little bit simpler because in this case the controller, at least right now, does not have to do any additional work. So all we have to do is return maddressbook.delete entry, and we pass through the entry. So we in one direction pass through just the entry to the address book, and on the other side whatever result code comes back we return to our caller. So that's it, and with that implementation the controller class is already done. Great. So we now have our business logic finished, as well as the controller to access the model data. So the next thing is to wire together our UI and the remaining system. So for this, let's go to the main window, and that one now requires an instance of our AddressBookController to work. So let's use include AddressBookController. Okay, and we should of course use these ones instead. And let's give it an AddressBookController private member variable colon mcontroller. Okay, so here the same applies as for the controller itself. Instead of the main window having to create its own controller class, I would recommend you pass in an instance via the constructor, as this allows you to better test your code afterwards. Okay. And okay, here as well, let's add an assertion. Just to be on the safe side. Okay, if we now try to compile our project, we should see that this is failing because, right, first of all, I did typo somewhere, no? Yes, I've had a typo. So again, let's try. And now we get the error in the right place, which is in our main.cpp, which cannot work anymore, right? Because the main Windows constructor signature has changed. So, of course, we have to pass it a controller, and basically here is now the best place to create the objects that we want to use. So first of all, we create an address book. Second, we need an AddressBook controller. And remember, this one also requires an address book, so we just pass it in as first argument to the constructor. Like so. And for the main window, we just modify its call, so here we just pass pointer to the AddressBook controller that we just created. Now let's try again. Okay, takes a short second. But now it succeeded. Very good. So now our main window knows our AddressBook controller and could interact with it. The next thing is basically to first design our actual user interface. So in a perfect world, you would have a designer who, while you've written the code, already have done so. We're doing this sequentially and ourselves because it's just more fun. So first, let's remove the components that we added just for fun to our main window. And yeah, let's take a thought on how we could design this thing. So, what I could imagine, let's say we have an application with 2 pages, where initially one page is visible, where we get a list of all entries in our address book, And as soon as we select an entry, we go to second page, a details page, where the information about the selected contact is shown and where we can also directly edit the stuff. So let's do so. And for the pages, Qt already provides nice widget, which is this so-called stacked widget. So let's place it here. And next thing we have to, or we probably want to take this, or to cover the complete main window. However, we should probably not start by trying to do something like this. Well, because that won't work. So as a proof, if I select the main window again and resize this one, and then resize our page widget, you see it does not adjust in size. And we certainly want, if the user changes the window size, our page widget to adapt as well. So here, let us first of all shrink the main window a little bit, again, like so. And what we can do is we can right click on our main window and in the context menu select layout, and here we can select something like layout in a grid. So grid layouts, for example, allow you to lay out multiple objects, usually in a grid. There are others like the vertical or horizontal layout, which just form one row which is laid out horizontally or vertically. It's also useful, like in our case, where you have one widget that you want to cover completely another one, where otherwise you would have to provide code at runtime, which is of course not very nice. Good. Now let's check our current object tree. So you see this here on the right side. So we have our main window, the central widget, and here is a stacked widget that we just created. And here we already see two pages. Okay, so let's start to design the first page. And as we said, we want to show up the list of address book entries there. And for this, we can use something like the list widget. Okay, so let's put it here. And again, we can, as this is inside the page free floating, we have to, or we can right click in this case, or we could also right click here in the object inspector, or directly here in the designer, say layout and layout in a grid. So our first page is now completely covered with a list view, which will show the address book entries. Good. Now let's go to the second page. And here, as we discussed, we want to show the user the details about one selected contact, and also want to give him the chance to edit the contact. So for this we need something like labels, so we can indicate what we're showing there. Okay, label as component exists. So let's check in one for the name of our address book entries, one for the address, the birthday, and one for the list of phone numbers. Good. Now we need appropriate editor widgets. So for the name, we certainly want to have just one line of text. That's sufficient. And here also the line edit widget exists, which is perfect for this purpose. Okay, then for the birthday, for example, we could use date edit. So if we drag this in, also a quite small widget which allows you to define dates, which is quite enough for a birthday editor. Okay, and then we have next the address. So for the address, we actually would rather want to have multiple lines just because it's better readable. So here we can use the so-called plain text edit. So this is a multi-line text editing widget. Okay, like this. And we can just pull in another one to allow editing the phone numbers. Okay, so far so good. And here we might also want to add some controls to the bottom maybe that allows the user to save the changes that he did or to discard them and just go back to the listing. And for this we could either use multiple push buttons, that's one solution. However, as this already looks like a little dialog, it's better to use this dialog button box component. Why is that? This component takes care that the ordering of the buttons, OK, cancel, reset, whatever is available, is according to the used operating system. Because the order of these buttons is different on Windows compared to macOS, compared to Linux, compared to whatever else. Okay, so let's resize here a little bit. And next thing, of course, if the user now would start to resize the windows, it doesn't look nice because the objects remain where they are, and also we are wasting a lot of space here. And however, we don't want to manually lay this out, so again, layouts come to the help. So let's right click on any free space, layout, and again let's select a grid layout here. And now you see the widgets are laid out perfectly in this grid here, just as we require this. Okay, now before we continue, let's fine-tune the UI a bit. Of course, here we don't want it to say each time just text label, but we want to show the properties that we mean behind, so that we could directly change in the designer. So double click on a label, for example, to change the shown text. Okay, address, and last but not least, phone numbers. Okay, like that. Then for the buttons here, well, we could stay with OK and cancel. However, actually that's not really what we have in mind. So let's scroll down here in the property editor, which shows the active properties of the selected widget. And if you scroll to the very bottom here, we have the properties of QDialog button box. The above ones are derived from QWidget and then QObject in this case. And here we have this property standard buttons. So standard buttons are the some standard buttons that are predefined that can be used. So by default, for the dialog button box, OK and cancel are selected. So here instead we could use save. Okay. We could use discard. And we could also use something like reset. So if the user did some mistake, he can immediately reset the entry to its saved defaults. Okay, that's one thing. Another thing is naming of the placed widgets. The thing is, whatever widgets or objects you see in this tree here will be available in source. And what you see here, objects, that's already the name that we will be using in the source code. And there we definitely don't want to use something like page 1 on page 2, just because it does not tell us anything. So instead, let's give nice names to the objects here. So you can also do this by just double clicking on an entry. And our page 1, we should rename this, for example, to just list page, as this is a page showing in the end the list of entries. Page 2 could be named details page. Okay. I think the labels are just fine because we never will really use them in the source code, so it's fine to keep them at their generated name. However, for the editors, we probably want to pick some better names. So for the line edit here, which is for our name, we can call this name edit. Date edit gets birthday edit. Okay. The first plain text edit, and here it starts to get interesting, or would have been interesting if we use the auto-generated names. Let's rename this to address edit, and now the second one gets phone numbers edit. Okay, perfect. So now let's go back to our list page. Now only one thing is missing: how to add and remove list entries, because we have added no controls in this page for this. Well, we could do so now. That's one possibility. Another possibility is we could also just use a menu for that, and to create a menu, just click on the type here, entry, and start typing. So let's create a top level menu called entries. Okay, and by pressing enter, the menu is created, and you see you get a already open menu here. And now we can add menu entries by just typing again and pressing enter. Okay, so which menu entries do we need? We need something to create new entries. So let's call this add. We need something to edit an item. So as after the user, let's say, clicked on an entry, that we can, or then this menu option will bring us to the second page, to the details page. Okay, and we need a third menu entry, which is of course for removing. Okay, good. So next, let's close the designer. So you can use the shortcut Control and W for this. Of course, save it before. Okay. So next, let's really make use of our controller in the main window and show something in the UI instead. Okay, so first of all, let's handle creation of new entries. For that, we go into the main window header and add a new section, public slots. Okay, so what are slots? So we already talked about signals. Signals were events that you could emit to let the world know that something happened with your object. Slots are basically the reverse. So you could connect a signal to a slot, and whenever the signal is emitted, it kind of calls the slot, so you can do some work to react on according signals. So it's like a callback function, for example, in C, just more advanced if you want like it. Good. So how does a slot look like? So slots usually also should have a void return value. Then the name of the slot. So let's also use create entry. And in our case, it does not take any parameters. Why is that? So we are going to connect the add menu entry to this slot. So whenever a user clicks this entry, we want the actions that we defined in this slot to be executed. And as triggered signal does not have any parameters, at least none that are of interest for us, we just define the slot as having no parameters at all. Good. Now let's add an implementation. And how could this look like? So first of all, let's try to create an address book entry. Okay, so easy. However, that only has created the entry in our model. The UI has not yet been updated, of course. That's what we're going to implement next. So first of all, let's check whether creation succeeded. And if this is the case, we next are going to add a new entry in our list widget. How to do this? Well, again, pretty easy. We use UI, which is kind of a handle to the component that we are or that we added in our designer to the main window. The list widget that we added is called, well, list widget. Very nice. So let's access this one. And that one has a method called addItem, which either takes an instance of QListWidgetItem, which is an instance of such an list entry. However, as we have none, we can alternatively just pass a QString. And here we just pass in the current name of the created entity. That's it. Okay. If we would execute the application right now, nothing would happen because we have not set up any connection between the add menu entry and our create entry slot here. Okay, how to do this now? Let's go back into the header, and this time let's add a new private helper method, which we are calling setup connections. And how does it look like? So here we now can set up the connections between, for example, our user interface controls and the slots that we defined in our main window class. A connection can be established by using the connect method, which is a method of QObject again, which usually takes 4 parameters. The first is the object that emits a signal. In this case, it's UI action add. So that's the action that is behind the add menu entry. Next thing is the slot definition. So in good old days, the signal definition. In good old days, that looked like that. You used the signal keyword in capitals, and then already the auto-completion pops in. So here we get the available signals of the QAction class, and what we require is actually the triggered signal. Okay. Now, the fourth parameter is the receiving object. In this case, it's just the main window class itself. And last one is the slot that we want to be executed whenever the signal occurs. So in this case, create entry. Okay. So whenever the action add is now clicked in the menu, hence it's triggered, signal is emitted, the create entry slot of this main window instance will be executed. Okay. Of course, we also want to execute this once in the constructor. And now let's give it a try. So run your application, save all files. Okay, again, it takes a moment to build. And here we are. And from the menu, let's select entries add, and voila, here we are. So far, so good. Now let's do the reversing. So let's get rid of items again. How to do this? First of all, we want to add a new slot definition. And how could it look like? So first of all, it's a good idea probably to find out the currently selected entry. So list item is UI list widget dot, and oh, very good, the list widget class already has a method called current item. So whenever this returns a valid instance of QListWidgetItem, we can continue. Okay, latest now we should realize that we have a little problem. Now we have the list widget item. However, what we actually require is the address book entry behind. So there's in fact a one-to-one connection between the two. However, right now that's not modeled, right? Because after creating a new entry, we also added a list widget item, okay, but we never made up a connection of the two. And now in the delete entry method, we are for now not able to find out which entry belongs to this list widget item. So to remedy this, let's go back to the header and let's include another header, qhash, which provides a hash map implementation. And what we can do as a very simple workaround, we define, and of course I need another forward declaration. We just define a mapping from QListWidget items to address book entries. Okay, and now let's revisit the create entry method. So here, just let's insert a new pair. So the first one is the list widget item, which will become the key in the map. And what do we pass in here? So if we check the add item method, you see in the help that pops up, it returns a void value. Okay, so how to get the list widget item instead? So pretty easy. You can use UI list widget dot item. So item is a method that gets as input the row number that you want to query and then returns the corresponding list widget item for this row. Okay, and what is the row? So using add item adds entries always to the end of the list widget. That means we basically need to know how many entries are in the list after we added our new entry and just subtract one of that number. Okay, so UI list widget, and as you could expect, it has a method called count, which will return the current amount of list items that this list maintains. And here we just subtract one, and here we go. Now we have the list item. We can pass this as the first argument to insert, and as the second argument the value we pass the entry. Okay. With that information now in place, we can go back to our delete entry implementation. Here we can get to the entry exactly the other way around. So we use entries dot value, and here we pass in the list items that we just got. Okay. So usually this check should be or should not be mandatory, because if we watch out, only valid list item entry pairs should be in our map. However, for the sake of safety, let's just check whether entry is set accordingly, and continue. So next thing is we want to really get rid of this item. And how do we do this? By using our controller again and delete entry, like so. And if you remember, our controller returns true whenever the deletion of an entry was successful. If it was successful, we also want to remove the list item from the screen, of course. So to do this, we just use delete list item, like that. Okay. And of course, what we also don't want to forget, entry map dot remove list item. So we remove the mapping from that list item to the entries that we created before. Okay, so far so good. Now let's extend our setup connections method a little bit. And now I want to show you another possibility to connect signals and slots. So this approach where you're using the signal and slot keywords, that's coming from older Qt versions already. While this is still working, it has a little drawback. Because in this case the connection is made at runtime. However, there is no chance to first of all check whether the parameter lists are matching at compile time, point 1, and point 2 is that it's not even a check possible whether a particular signal or slot still exists. If one of the two conditions fail, what will happen is you get an error message or a warning message at runtime of your application. However, the application in general will just continue to run. So finding certain issues in your UI could be really painful if you're not watching out, and for example after a refactoring session some slot names on your code have changed, and then certainly from one day to the other, if the user presses a button in your application, it's just not doing anything anymore, which would be bad. So a better alternative is using the newer C++11 style to connect signals and slots. So how does it look like? Actually pretty similar. We start with the source object that emits a signal, in this case our action remove menu entry. And now we use ampersand. The auto-completion already suggests QAction, so that is the class behind the action remove member in UI. Then colon, and now again the signal name, in this case triggered. Okay. And again, third parameter, the receiver object. This is again the this pointer. And here, same game. Ampersand, then main window, the current class. And here the slot is called delete entry. That's it. Now let's try to build. Should work out. And now if we start the application, let's first add a few entries. And now we can also remove them again. Very good. Works as expected. So the next thing is to implement actual editing of the entries. So for that, again, let's add another slot here called edit entry. And how could this look like? So first of all, we have to again get our entry here. Good. So let's just copy paste. So after we have the entry, how to proceed now? So the first thing you probably want to do is changing the page. So you remember by default we're showing the list page, which shows the list of all address book entries. And now when we select editing, we want to switch to the details page. That means UI, stacked widget, and that one has a method called setCurrentWidget. And here we can just pass the other page that we created. So UI detail page. Okay, point 1. Point 2, during we're editing, we certainly want to disable the entries menu. Because otherwise the user would still be able to add or remove entries, which doesn't make a lot of sense. Okay, so UI menu entries set enabled, and we set this to false. So this will cause the menu to be disabled, so it's displayed grayed out and the user will not be able to select any of the options in the menu. Okay, quite fine. So then the last thing we need to do is basically updating the UI in the detail page. So you remember we have defined various editor widgets, so we have to fill their contents with the current values from the entry. So let's start with name edit, UI name edit dot, and there we can use set text to set the text of the line edit, and here we pass entry dot name. The same for the birthday, quite easy, UI birthday edit, set date in this case, and we pass an entry dot birthday. For the address, it's again also quite easy. So here we're using set plain text, and here we pass in as input entry dot address. Good. For the phone numbers, it's a bit more, let's say complicated. So there in our data model we decided to store them as a list of strings, which is still quite fine. But however, to use the plain text editor, we now have to concatenate these lines. However, that's also quite easy. So you'll see it's also just a one-liner, UI phone numbers edit set plain text from entry phone numbers, and here we can use the join method, and we are using a line break character to join the various lines together. Good, that's it. So we could add another connection here. UI action edit good. Now let's run the application again. And it works. So now we could just start typing stuff here. Oh, but of course we have not yet implemented the buttons. So we're basically locked in this page. So let's close the window again, and let's just add an implementation for the missing 3 buttons there. So first of all, let's return to the header and let's add according slots. So save entry, discard entry, and reset entry. Very well. Let's start with the easiest one, discard entry. So if the user clicks on the discard entry, we don't care about the current contents of the editors, we just return to the list page. That means UI stacked widget, set current widget, and we just set it back to UI dot list page. That's one thing. And we also have to remember to re-enable our entries menu. Okay, like that. Let's go back to the header. Next, let's take care for the reset entry. So that one is pretty simple actually, because we can copy and paste a lot of code from the edit entry method, like that. We can remove this and this, because we know we already are in the details page, and hence we know the state of the stack widget, and we know the state of the entries menu, so we don't have to change this again. All we have to do is reapply the current values of the selected entry and updates or re-updates the editor widgets accordingly. And seeing this, what we can do is actually replace this here, kind of doing some code sharing, by a call to reset entry. Okay. Nearly done. Last thing is save entry. That's a little bit more, well, not more complicated, but again, more typing this time. So again, we have to get the list item, the entry. However, instead of setting the editor contents, we want to do the reverse thing. So we want to use entry.setName, and here we're taking UI name edit.text, which is the getter for the text property, which is currently shown. Next, entry set birthday, UI birthday edit dot date, then entry dot address, set address, and here we pass UI address edit, and here to get contain text we have to use toPlain text. Okay, and the last thing, entry dot set phone numbers. Okay, and here we can take UI phone numbers edit, again toPlain text, but remember we want to split this up, so we can use dot split on the return string to split the string up on each new line character and return a string list with the various lines. Okay, so far so good. However, we also have to take care to go back to the list page. However, for that we already have the discard entry implementation, so let's just use this one. Okay, so that will cause stacked widget to return to the list page and the menus or the entries menu to get enabled again. So now we're nearly done. All we need to do is setting up the connections. So connect, and this time getting the source object will look a little bit different. So we have this button box widget. However, that one is creating the buttons dynamically depending on the selection of standard buttons that we made. So to get to the instances of these standard buttons, we can use the button method and pass in a standard button. So we use QDialog button box, and for example save, which represents the save button, and ampersand. Oh, something is missing. So that's because the auto-completion does not see the QPushButton class, which comes back from the call to button. So let's include this QPushButton. Scroll down again and retry. Okay, that looks better. QPushButton, clicked. And we're connecting this to our save entry slot. Now let's copy paste this. So for the discard one, we want to connect it to the discard entry slot, and the same for the reset button. We want to bind this to the reset slot. Okay. Now, nearly perfect. There's still one tiny thing missing. But let's first try this out. You'll see in a second. So let's create a new entry, edit it, and let's try save. Ooh, hasn't it worked? Let's try again. Oh, but here we still get test. Why is that? The thing is, we forgot to update our list widget. So for that, let's revisit the save entry implementation. And here we want to add something like this: list item dot set text from entry dot name, for example. Okay, let's try again. So create a new entry, use edit, let's save this one. Okay, the name got updated accordingly. Great. And now let's test if this is also working. Now if we use reset, yes, it goes back to the previously stored versions. And if we, let's say, delete that and say discard, we also just go back and okay, as expected. Great. So that's it.